everyone, welcome to our channel. Today let us learn the important topic in big data, that is big data architecture. Let us go into our topic. There are 5 layers in big data architecture. Let us see each layer one by one and their corresponding functions. Layer 1. First we are identifying whether the given source of data is internal or external. Their corresponding functions are sources for ingestion of data. Here ingestion is nothing but loading. First we are loading the data and then pushing the source from layer 1 to layer 2 or pulling the source from layer 2 to layer 1 for loading the data. It considers a data types like database such as int, float, double. Files. In files we have 6 different types of files, that is audit file, transaction file, programming file, execution file, working file and master file. Web or service, like in service we have physical and logical service, where physical service is directly available, which is the open source for everyone, and in logical service which is not available directly, that are used for external purpose. The last function of first layer is data formats. In data formats we have structured the data. It contains table which has rows and columns which follows some specific format, example Excel. Unstructured data which does not have specific format, example audio, video, images. And semi-structured data, the combination of structured and unstructured data is known as semi-structured data, example XML, email. All this data is collected in layer 1 for loading purpose. Layer 2 is data ingestion and acquisition, that is for loading data and filtering. Their corresponding functions are ingestion using ELT tool. ELT abbreviation is extract, load, transform. That is first we are extracting data and next loading the data and then transforming the data. Next is the data semantics. It is nothing but we can replace the data what we require. Append is adding the extra data, aggregating the data. Compact is the overall data and fuse is cleaning the data. And then pre-processing the data by checking the validation of data and transformation or transcoding requirements. The last function of layer 2 is loading the data from source in batches or real time, that is a group of data is sent in batches. Real time is nothing but there will be some second difference in it. Layer 3 is data storage, where to store the data. Their corresponding functions are first considering some types like historical data, that is already existed data, or incremental is nothing but already existed data, we are adding some more data into it. Formats, as we know, structured, unstructured or semi-structured data. Compression is compressing the data size. Frequency of incoming data is how many times the data is repeated. And patterns of querying, if there is any queries it will be rectified it. And data consumption is how to consume the data. HDFS, Hadoop distributed file system, which handles the large data set. In this we have scaling. In scaling we have scale up and scale down. Scale up is the vertical scaling, is adding more resources to easily handle peak workloads. Scale down like CPU, memory and disk to increase more computer power and storage capacity. Scale down is the horizontal scaling, that is adding extra nodes. Here nodes is nothing but computers. Self-managing is monitoring and maintaining, and self-healing is network's ability to recover from failures. And next, Spark mesos or SPs, restart via the resource manager. The last function of layer 3 is NoSQL data stores, that is not only structured query language stores such as HBase, MongoDB, Cassandra, Graph database, where HBase is open source, anyone can use it. MongoDB is to store the data in key and value pairs, that is in document format. Cassandra, which handles the large amount of data across many commodity servers. Graph database is the single purpose platform for creating and manipulating graphs, where graphs contains nodes and edges. Layer 4 is data processing, that is how to process the data. Their corresponding functions are, here we use processing technology like MapReduce. It is a programming model or pattern within the Hadoop framework that is used to access big data stored in HDFS. Hive, that allows users to read, write and manage petabytes of data using SQL. SQL is structured query language. Pig, it is an open source high level data flow system. Spark, it is a general purpose distributed processing system used for big data workloads. processing in real time, some second difference in it, and scheduled batches is assigning work by scheduling the time, and hybrid. The last function of layer 4 is synchronous or asynchronous process. In synchronous process, if many work is given, first it does the work and goes to the next work, whereas asynchronous process, the work is done parallelly, it does not wait. Layer 5, which is the last layer in big data architecture, is data consumption. Their corresponding functions are: once data processing is done, we need to consume the data and export the data set to cloud, web, etc. to store for future backup. Data usages are BPS, that is business process, BIS, that is business intelligence, and gaining some knowledge, discovery about the data. The last function of layer 5 is analytics. It is used for analysis purpose. Real time, there is some second difference in it. Near real time, example streaming, radar system, bank ATMs. Scheduled batches, where the data is collected over time then fed into analytic systems. Visualization, that is for better understanding about overall data. This is all about big data architecture. If you like this video, please do like and subscribe it. Thank you for watching.